All right, this is my second video on recursive rules. So I'm going to show two more types of examples dealing with recursive rules. So the first one, we're going to write a recursive rule from the explicit rule. So a quick reminder, our recursive rules, arithmetic, we need to know what A1 is, and we know AN equals AN minus 1 plus D. And again, the key things are I need to know what A1 is, I need to know what D is. And for geometric, still need to know A1, and we're going to have AN equals R times AN minus 1. So this first one, we have AN equals 3 plus 4N. Now, I'm not quite sure if I'm dealing with arithmetic or geometric. This one's not as obvious to me. So things that you can do, and you can do this for anyone, is just figure out the first few terms. Figure out that pattern. So I'm going to figure out what A1 is, A2 is, and A3. To try and get a sense of, well, what is this pattern, so I could pick out, first off, what is A1, because I need to know that, and D or R, what am I dealing with? So if I want to know A1, that means I replaced my ends with 1. So on the right side, I'm going to replace my ends with 1. So I have 3 plus 4 times 1, which is 4 times 1 is 4, plus 3 is 7. So then A2, I'm going to have 3 plus 4 times 2. 4 times 2 is 8. I'm going to have 11. And then 3 plus 4 times 3. And I'm going to end up with 15. So looking at those first few, I go from 7 to 11 to 15. So I could kind of get a sense of arithmetic or geometric, and this is going to be arithmetic. And also, I'm going to be able to tell that this increases from 7 to 11 to 15. I know not only that I'm dealing with an A1 of 7, because that's the first term, but I also know that my D is 4. So my answer for the recursive rule is going to be A1 equals 7. I knew that. And now I have to write the recursive rule. So I'm going to have AN equals AN minus 1 plus D, which in this case is 4. So that in red is your complete recursive rule. Has the first term and what to build off there. So for my second one, I could go through and figure out A1, A2, A3, but I can actually look at this one, those are that a little bit more advanced, and I know right away what A1 and what R is. And I know this is geometric. The reason I know is the explicit rule for geometric series or geometric sequence is AN equals A1 parentheses R raised to the n minus 1. Notice this form is almost exactly the same as this one, where A1 represents -7 and R is in place of 6. So I know A1 and I know R. So from there, I'm going to write in red again for my answer. I'm going to have for my recursive rule A1 equals -7. And I'm going to have AN equals 6 times A with a subscript n minus 1. So that would be my recursive rule. One last final example. We're going to write the explicit rule from the recursive rule. Now you will have a formula sheet. The explicit rules again for arithmetic is AN equals A1 plus n minus 1 times D. And for geometric, it's AN equals A1 parentheses R raised to the n minus 1. So those are the explicit rules. They gave me the recursive. And again, the important things are I need to know what A1 is, and I need to know either my D term or R. Those are the important pieces. So just being familiar with these, you can kind of figure that out. So first thing they give me is they tell me A1 is equal to 3. Great, good start. Now I need to figure out D or R. Now with recursive, it's not that difficult. Notice how I have AN equals AN minus 1 minus 6. This is telling you how to construct the sequence, and it's saying you're going to subtract 6. Well, if you subtract 6 every single time, that's an arithmetic movement. So I'm going to, or an arithmetic setup there. So I know I'm going to have D, and in this case, D is going to be -6. So I know A1, I know D. I'm going to plug in for my explicit rule and then make sure it's simplified. So I'm going to have AN equals A1, which in this case is 3, plus parentheses n minus 1 times D, where in this case D is going to be -6. Now this isn't done. We need to make sure it's simplified, so I'm going to take that -6, multiply on through. So I'm going to have 3. Negative 6 times n is negative 6n. Negative 6 times negative 1 is positive 6. So working with this, I need to combine like terms. This n term's kind of all by itself, so I end up with a negative 6n, and then 3 plus 6 is 9. So my explicit rule is an equals negative 6n plus 9. That is the explicit rule. So the next one, I need to figure out what a1 is and d or r, whatever we're dealing with. So they tell me a1 is negative 2. Now let's look at the rest of the recursive rule. It says if you want to find an an term, you're going to take 3 times an minus 1. Well, if we're multiplying by 3 every single time, that is a geometric sequence. So r is going to be 3. So I know a1, I know r, so I need to put it together in the explicit. So I'm going to have an, and I'm going off the explicit formula for geometric, which is a1 r to the n minus 1. So I need to have a1 first, which is negative 2, parentheses r, which is 3, exponent n minus 1. And that would be my explicit rule. So that was the second video on recursive sequences.